According to power company guidelines, there should be a minimum of 3 feet of clearance in front of the meter. It was stated that there is a bit over 2 feet of clearance, which is not ideal, but may not be a significant issue during the inspection. It's advisable to consult with the power company directly to confirm their specific requirements. The county inspector stated that overhead wires pose a concern, even if the hot tub is covered by a patio attached to the house. There are no specific exceptions mentioned in the code for covered patios. Considering the county inspector's concerns, it is reasonable to address the issue with the contractor. One can request either, firstly, relocating the overhead wires. This is the most comprehensive solution to eliminate potential safety hazards. Secondly, raising the overhead wires. If relocation is not feasible, raising the wires to a higher elevation could potentially meet the county's requirements. Some additional steps that can be taken are firstly, contacting a licensed electrician. They can provide professional guidance and ensure that all electrical aspects of the hot tub installation meet code requirements. Secondly, communicate with the contractor clearly. Explain the concerns and expectations, and work together to find a satisfactory solution. Thirdly, consider relocating the hot tub. If all other options are not feasible, relocating the hot tub to a different location where it does not conflict with overhead wires or meter clearance may be necessary. It's important to prioritize safety and adhere to local code requirements. By addressing the concerns with the contractor and taking appropriate actions, one can ensure that the hot tub installation is both compliant and enjoyable. For electrical safety, it's crucial to understand and adhere to the National Electrical Code, or NEC, which provides comprehensive guidelines for electrical installations. Article 680.42 of the NEC specifically addresses the requirements for outdoor hot tubs and spas, focusing on clearances from overhead conductors. This section mandates that hot tubs must maintain a certain vertical and horizontal clearance from overhead power lines to prevent electrical hazards. Firstly, the vertical clearance is the distance between the top of the hot tub and the lowest point of the overhead wires. The required clearance varies depending on the voltage of the overhead power lines. For example, if the power lines carry 0 to 750 volts, the minimum vertical clearance is typically 10 feet. For higher voltage lines, such as those carrying 751 to 22,000 volts, the clearance increases to 12 feet. These clearances are essential to prevent accidental contact with energized conductors, which could result in severe electric shock or electrocution. Secondly, the horizontal clearance is the distance between the edge of the hot tub and the closest overhead wire. Similar to vertical clearances, the required horizontal clearance depends on the voltage of the overhead power lines. For lines carrying 0 to 750 volts, a common requirement is a horizontal clearance of at least 8 feet. For higher voltage lines, this distance increases proportionally. The purpose of horizontal clearance is to ensure that even if someone reaches out or an object is extended from the hot tub, there is a safe buffer zone from the electrical conductors. Article 680.43 of the NEC provides detailed guidelines on bonding requirements for hot tubs, which are crucial for preventing electrical shock hazards. Bonding involves connecting all metal parts of the hot tub and its surrounding equipment to create an electrically conductive path back to the electrical panel. This path ensures that if a fault occurs and any metal part becomes energized, the fault current can quickly flow back to the source, tripping the circuit breaker and cutting off power to the hot tub. The main components that need to be bonded include firstly, the metal parts of the hot tub structure itself. This includes the metal frame, any metal supports, and any metal accessories attached to the tub. Secondly, all metal piping systems connected to the hot tub, such as water supply lines and drain pipes, must be bonded. This prevents these pipes from becoming energized due to a fault in the electrical system. Thirdly, any metal equipment located within 5 feet of the hot tub, such as pumps, filters, heaters, and control panels, must also be bonded. This ensures that all nearby metal parts are at the same electrical potential, reducing the risk of shock. Fourthly, the bonding conductor, typically a solid copper wire of at least number 8 American wire gauge or AWG, must be connected to all these metal parts and then routed back to the grounding terminal in the electrical panel. This creates a low impedance path for fault current to flow, facilitating the rapid operation of the circuit breaker. In addition to bonding, the NEC also requires the use of ground fault circuit interrupters or GFCIs for hot tubs. A GFCI is a safety device that monitors the current flowing in a circuit and quickly cuts off power if it detects a ground fault, which is a situation where current is leaking to ground. Article 680.42 of the NEC mandates that all electrical circuits supplying power to a hot tub must be protected by a GFCI. This includes the circuit for the pump, heater, lighting, and any other electrical components of the hot tub. The GFCI is designed to trip at a very low current level, typically around 5 mA, which is well below the level that would cause serious harm to a person. When a ground fault is detected, the GFCI can trip in as little as 1/40th of a second, quickly cutting off power and preventing electric shock. The GFCI protection is typically provided by installing a GFCI circuit breaker in the electrical panel. This breaker not only provides overcurrent protection for the circuit but also monitors for ground faults. Alternatively, a GFCI receptacle can be installed near the hot tub to protect the circuit. Regular testing of the GFCI is recommended to ensure it is functioning properly. This can be done by pressing the test button on the GFCI device, which should cause it to trip and cut off power. If the GFCI does not trip when tested, it should be replaced immediately. For underground wiring to serve a hot tub, the NEC specifies requirements for the type of wiring and the depth at which it must be buried. Article 300.5 of the NEC outlines the general requirements for underground wiring, while Article 680 provides specific requirements for hot tubs and spas. Firstly, the type of wiring used for underground installations must be suitable for direct burial and resistant to moisture and corrosion. Commonly used wiring types include underground feeder or UF cable and rigid metal conduit or PVC conduit containing individual conductors. UF cable is a type of cable that is specifically designed for direct burial applications. It consists of insulated conductors encased in a moisture-resistant jacket. PVC conduit is a type of plastic pipe that can be used to protect individual conductors. It is lightweight, easy to install, and resistant to corrosion. Rigid metal conduit or RMC can also be used, providing even greater protection against physical damage. Secondly, the depth at which the wiring must be buried depends on the voltage of the circuit and the type of wiring used. For circuits operating at 120 volts or 240 volts, UF cable must be buried at least 24 inches deep. If PVC conduit is used to protect the wiring, the burial depth can be reduced to 18 inches. RMC must be buried at least 6 inches deep. These burial depths are intended to protect the wiring from physical damage, such as from digging or landscaping activities. Thirdly, when running underground wiring, it is important to provide adequate protection for the wiring where it emerges from the ground. This can be done by using conduit to protect the wiring as it transitions from underground to above ground. The conduit should extend at least 18 inches above grade and be securely fastened to a support structure. Fourthly, it is also important to mark the location of underground wiring to prevent accidental damage during future digging or excavation. This can be done by burying a warning tape above the wiring or by installing markers at regular intervals along the path of the wiring. The NEC specifies requirements for disconnect switches for hot tubs to ensure that the power can be easily and safely shut off for maintenance or in case of an emergency. Article 680.12 of the NEC requires that a disconnecting means be provided within sight of the hot tub and readily accessible to users. Firstly, the disconnect switch must be capable of disconnecting all ungrounded conductors supplying power to the hot tub. This means that it must be able to simultaneously shut off all hot wires, typically in a 240 volt circuit. Secondly, the disconnect switch must be rated for the voltage and current of the hot tub circuit. The voltage rating must be equal to or greater than the voltage of the circuit, and the current rating must be equal to or greater than the maximum current that the hot tub draws. Thirdly, the disconnect switch must be located within sight of the hot tub. This means that it must be visible from the hot tub location without any obstructions blocking the view. The purpose of this requirement is to ensure that anyone working on the hot tub can easily see whether the power is on or off. Fourthly, the disconnect switch must be readily accessible. This means that it must be easily reached and operated by users of the hot tub. The switch should not be located behind any obstructions or in a difficult-to-reach location. The disconnect switch can be either a circuit breaker in the electrical panel or a separate switch installed near the hot tub. If a circuit breaker is used as the disconnect switch, it must be clearly labeled to indicate that it controls the hot tub circuit. A separate switch can be either a toggle switch or a pull-out type switch. It is important to choose a switch that is suitable for outdoor use and rated for wet locations. The NEC also addresses the requirements for lighting around hot tubs to ensure safety and prevent electrical hazards. Article 680.43 of the NEC provides specific guidelines for the installation of lighting fixtures near hot tubs and spas. Firstly, all lighting fixtures installed within 5 feet of the hot tub must be GFCI protected. This includes both 120-volt and 240-volt lighting fixtures. The GFCI protection can be provided by a GFCI circuit breaker in the electrical panel or by a GFCI receptacle installed near the lighting fixture. Secondly, lighting fixtures installed within 12 feet of the hot tub must be suitable for wet locations. This means that they must be designed to withstand exposure to moisture and water. Lighting fixtures that are rated for wet locations are typically marked with a UL listing. Thirdly, lighting fixtures should be positioned so that they do not create glare or reflection on the water surface. This can be achieved by using shielded lighting fixtures or by positioning the fixtures so that the light is directed away from the water. Fourthly, low-voltage lighting systems, such as those operating at 12 volts, are often used for lighting around hot tubs. Low-voltage lighting systems are generally safer than 120-volt systems because they reduce the risk of electric shock. Low-voltage lighting fixtures must be powered by a transformer that is specifically designed for outdoor use and rated for wet locations. The transformer should be located in a dry location and protected from the elements. The NEC also allows the installation of underwater lighting in hot tubs, but these fixtures must meet very strict safety requirements. Underwater lighting fixtures must be specifically designed and listed for underwater use. They must be installed in accordance with the manufacturer's instructions and must be GFCI protected. When installing electrical equipment near a hot tub, it is important to maintain proper clearances from the water. Article 680.43 of the NEC specifies the minimum clearances that must be maintained between electrical equipment and the water surface of the hot tub. Firstly, electrical equipment that is not specifically designed for wet locations, such as receptacles and switches, must be located at least 5 feet away from the water's edge. This clearance is intended to prevent accidental contact with water, which could create an electrical hazard. Secondly, electrical equipment that is designed for wet locations, such as lighting fixtures, can be located closer to the water, but they must still be installed at a safe distance. The specific clearance requirements vary depending on the type of equipment and the voltage of the circuit. Thirdly, all electrical equipment installed near a hot tub must be properly grounded. Grounding provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and cutting off power in the event of a fault. Fourthly, it is important to avoid running electrical cords or extension cords near a hot tub. Electrical cords can be easily damaged or come into contact with water, creating a serious electrical hazard. If temporary power is needed near a hot tub, it is best to use a portable GFCI protected power outlet. Before starting any electrical work near a hot tub, it is important to disconnect the power to the circuit of the electrical panel. This will prevent accidental electric shock while working on the electrical system. It is also important to follow all applicable electrical codes and safety guidelines. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Proper maintenance of the electrical system is essential for ensuring the safety of a hot tub. Regularly inspect the electrical equipment for any signs of damage or wear. Check the GFCI devices to make sure they are functioning properly. Keep the area around the hot tub clear of any obstructions that could block access to the electrical equipment. If you notice any problems with the electrical system, such as flickering lights or a tripped circuit breaker, have it repaired immediately by a qualified electrician. It is also important to protect the electrical equipment from the elements. Cover the equipment during periods of heavy rain or snow. If the equipment is exposed to excessive moisture, it can corrode and become damaged. By following these electrical safety tips, you can help ensure that the hot tub is safe to use and that you and others are protected from electrical hazards. When dealing with overhead power lines, it is crucial to maintain a safe distance and follow specific guidelines to prevent electrical accidents. Overhead power lines carry high voltage electricity, and contact with them can be fatal. Always assume that overhead power lines are energized and treat them with extreme caution. Firstly, maintain a minimum clearance of at least 10 feet from overhead power lines. This clearance applies to all objects, including ladders, poles, antennas, and tree branches. Secondly, be aware of the height of vehicles and equipment when working near overhead power lines. Tall vehicles, such as dump trucks and cranes, can easily come into contact with overhead power lines if they are not operated carefully. Thirdly, never attempt to move or touch a downed power line. Downed power lines can still be energized and can pose a serious electrical hazard. If you see a downed power line, stay away from it and call the power company immediately. Fourthly, be careful when working with metal objects near overhead power lines. Metal objects, such as ladders and tools, can conduct electricity and can create a path for electricity to flow to the ground if they come into contact with a power line. Fifthly, if you are working near overhead power lines, wear rubber-soled shoes and avoid touching any grounded objects. Rubber-soled shoes can provide some insulation from electricity, and avoiding grounded objects can prevent you from becoming a path for electricity to flow to the ground. Sixthly, if you are working on a construction site or other area where overhead power lines are present, make sure that all workers are aware of the potential hazards and are trained in safe work practices. Seventhly, if you are planning to do any digging or excavation work, call the local utility companies to locate any underground utilities before you begin. Digging near underground utilities can damage them and create a safety hazard. Eighthly, if you are planning to install a swimming pool, hot tub, or other structure near overhead power lines, consult with the power company to ensure that the structure meets all applicable clearance requirements. Ninthly, if you have any questions or concerns about overhead power lines, contact the power company for assistance. The power company can provide information about safe work practices and can help you to identify and avoid potential hazards. Tenthly, always remember that overhead power lines are dangerous and should be treated with respect. By following these guidelines, you can help prevent electrical accidents and ensure your safety. Consider the impact of trees near power lines. Trees can pose a significant hazard to power lines if they are not properly maintained. Tree branches can grow into power lines, causing outages, fires, and other problems. It is important to keep trees trimmed away from power lines to prevent these hazards. Firstly, contact the power company if you have trees on your property that are growing near power lines. The power company can provide information about tree trimming services and can help you to identify any potential hazards. Secondly, do not attempt to trim trees near power lines yourself. Tree trimming near power lines is a dangerous job that should only be performed by qualified professionals. Thirdly, be aware of the potential hazards of falling tree limbs. Tree limbs can fall onto power lines, causing outages and other problems. If you see a tree limb that is hanging dangerously close to a power line, contact the power company immediately. Fourthly, plant trees a safe distance away from power lines. When planting trees, consider their mature height and spread and make sure that they will not grow into the power lines. Fifthly, if you have trees that are already growing near power lines, consider having them removed or relocated. Removing or relocating trees can eliminate the potential hazards that they pose to power lines. Sixthly, work with the power company to develop a tree management plan for your property. A tree management plan can help you to identify and manage trees that pose a hazard to power lines. Seventhly, be aware of the local regulations regarding tree trimming near power lines. Many local governments have regulations that govern the trimming of trees near power lines. Eighthly, be responsible for the trees on your property. As a property owner, you are responsible for ensuring that the trees on your property do not pose a hazard to power lines. Ninthly, report any problems with trees near power lines to the power company. If you see a tree that is growing into a power line or a tree limb that is hanging dangerously close to a power line, report it to the power company immediately. Tenthly, always remember that trees near power lines can be dangerous and should be treated with respect. By following these guidelines, you can help prevent electrical accidents and ensure your safety.